Thank you, everybody, for joining Amaero's exciting webinar. This has been a great transition period for the company, as many longtime investors are aware. And today we have Hank Holland and Eric Bono, who are going to be discussing some additional new information for investors in the company. My name is Russell Katz. I'm the account manager for Amaero and work for the Capital Network. With that, I'm going to turn it over to Hank, who will discuss in greater detail.
Great. Thank you, Russell, very much. Hello and good morning in Australia. Go to page 2. Everyone at your convenience, if you would please read the obligatory notice and disclaimer language. We'll jump over it, but it is available on page 2 for your review. Next page, I'm going to give an overview. We prepared a presentation that provides an update on the facility in Tennessee, our operations, and the leadership team to highlight Amaero's competitive position in the industry and to underscore the timely opportunity for C-103 and the hypersonic space applications. Next page, please. I'd like to make a number of comments before turning the presentation over to Eric Bono. Number one, I could not be more enthusiastic about having Eric Bono join as my partner and join Amaero's President and Chief Technical Officer. As I conveyed to Eric when trying to make a compelling case for why he should join Amaero, his role in this opportunity is a fitting culmination of his experience over 28 years in powder metallurgy and advanced manufacturing. As Eric will discuss, we have assembled an industry-leading team with impressive technical, operational, and finance experience. Number two, global supply chain vulnerability was exposed during COVID. But the critical and national security nature of the vulnerability was amplified with the Ukraine conflict. Shifting geopolitical sands have coalesced national policy initiatives aimed at reestablishing U.S. and allied country capabilities that pertain to critical minerals, advanced manufacturing, and defense production. Relocating to the United States has many commercial advantages. These include the opportunity to potentially secure funding from federal programs such as the Inflation Reduction Act, the CHIPS Act, Defense Production Act Title III, the opportunity to potentially participate in classified defense projects, and the inherent attractiveness as a U.S.-based supplier to defense prime contractors. Finally, number 3, it's been an exciting and very busy 10 weeks. On the 13th of July, Amaero announced that it signed a lease on 9,300 square meter manufacturing and corporate headquarters in Tennessee. We announced economic development commitments from the state of Tennessee, Bradley County, and Oak Ridge National Lab. And we announced a 10-year commitment from Tennessee Valley Authority to provide incentives and a subsidized electricity contract over 10 years. Beginning on 27th of August, we announced key hires that positions Amaero as having an industry-leading team of thought leaders with operational expertise. On the 18th of September, we announced that the facility and equipment installation had been re-engineered such that we expect to install the first atomizer in the existing 9,300 square meter facility without adaptation, thus accelerating the expected installation date. On the 28th of September, this Thursday, the first atomizer is scheduled to arrive at the Port of Savannah, Georgia. The shell of our manufacturing facility has been completed, and with the final stages of design and engineering for fit-out, we expect construction of fit-out to commence next quarter. And 4, with this as a backdrop, we are very excited to announce that Amaero will dedicate production for the first atomizer to C-103, a niobium alloy with high-performance, heat-resistant properties that are critical to applications in hypersonics and space. Not since Sputnik in 1957 has the U.S. ceded a primacy defense capability to a threatening superpower. In the U.S., it's a top national security priority to establish a leading position in hypersonic weapon systems. Ironically, after 3 months in orbit, Sputnik burned up during a reentry, and this underscores the other commercial opportunity for refractory powder. The same high temperature properties that make C-103 critical for Mach 20 hypersonic applications make C-103 critical for heat shielding during reentry from space. After Eric provides commentary on our vision, our strategic direction, and our competitive positioning, I'll provide commentary on the commercial opportunity, and then we'll be happy to take your questions. With that, it's my pleasure to introduce Eric Bono, Amaero's President and Chief Technical Officer.
Fantastic. Thanks very much, Hank. Really appreciate it. Really appreciate my first time here being able to talk to everyone, and look forward to explaining our vision and maybe fielding some questions at the end. All right, so to jump into it, it's no secret or surprise, as Hank said, that the current global manufacturing ecosystem is uncertain at best. Lead times have stretched to years. Quality has become suspect on a global scale. It's become a national security imperative to reshore critical materials and manufacturing processes. And Amaero is uniquely positioned to satisfy several of those needs. As Hank alluded to, our initial plan was to expand the facility by 30,000 square feet, but the strong pull we received from the market for these high temperature refractory powders led us to re-examine the possibility of accelerating our schedule and fitting the atomizers into the current building. And it looks like we're going to be able to do just that. And that will allow us to start the building fit out in the fourth quarter of this year and start installing the atomizer in Q2 of 24. And as Hank mentioned, the first atomizer literally is going to be in port this week, and we're finalizing import documents right now. So next slide, please, Russell. So as I think we all know, nothing gets done without the right team. And we have the core team in place right now to execute on our ambitious goal to become the world leader in advanced material production and component manufacturing. The depth and breadth of experience that this team brings covers everything from advanced powder manufacturing through serial part production and everything in between. A quick look at some of the team's previous experiences illustrate our journey from applied R&D through high-scale production environments. And we are leveraging all of that experience to build a truly world-class company. Next slide, please. As I just talked about, we're at a point in history where the wave of offshoring that we've been experiencing is rebounding back at us in the forms of what we now call reshoring. The complex geopolitical landscape that we live in has created unacceptable supply chain disruptions for both raw material supply and component manufacturing. Now, the positive side of this situation is that it has created a massive economic opportunity for Amaero to position itself as the world leader in supply chain for critical powders. A large portion of this opportunity will also come from titanium powder, which will have a market size of over $4.5 billion by 2032. Next slide. So our flagship plant will be located in the heart of the Tennessee Valley. When the decision was made to come to the US and Hank was canvassing the country for our location, this Tennessee Valley jumped out as just a natural and perfect fit for us. They have a proven business-friendly attitude here and are centrally located to several potential key customers and R&D partners. In addition, we've secured a long-term electricity rate that will allow us to compete on a global scale for the next decade. And even at this early stage in our maturity, we are already kicking off development programs with some of these partners. Next slide. When you look at the powder side of our business, it's keystoned on an advanced atomization process that accomplishes three main things. Number one, it creates powder in a contact-free environment. What that means is that we create powder without our raw material coming into contact with anything that may contaminate it. That's why we call it contact-free. No other process can claim this. Secondly, while our other processes typically yield 20 to 25% of what we would call prime or high-value powder, we have proven the ability to have double that, north of 50% yield. This is an enormous economic advantage. As far as the other 50%, we're going to cover that in a couple slides. The last point I want to discuss, back one up. The last point here, I just want to touch on one more thing, is that we have the ability to trace our raw materials back to their very origin, literally the original melt. This is a little bit of a nuance, but it is a critical factor for our customers in the most demanding industries, such as aerospace and medical device manufacturing. Now, next slide, Russell, thanks. We want to really quickly hit on the scale of our plan. So in the not too distant future, we will have the largest production capacity for titanium, refractory, and specialty alloy powders in the United States. As Hank will expand upon in a couple minutes, our focus markets will be industries that demand the highest quality and traceability in powder, all while providing confidence that production level manufacturing is in place and stable. Next slide. So I mentioned a few slides ago that I was going to touch on this remaining 50% yield. So that's the point of this slide. So this prime powder that we talk about that we yield over 50% on is typically sold into the additive manufacturing space. And that commands the highest value. So that's where we want to sell it. And it's the fastest growing market. Where there's an opportunity for Amaero is with the other 50%. It can be consumed by our own and other component making modalities. As you can see, or we tried to illustrate in the chart here, we've laid out a plan to consume all of the powder that we generate. And this will truly set us apart from anywhere else in this space. A key technology to accomplish this is our hot isostatic pressing near net shape making technology. As that rolls off my tongue, we're going to have to come up with an acronym for that. But we'll go into this deeper in upcoming calls. But this technology allows us to manufacture very large and very complex components with what's often seen as off-size powder. These parts can be on the order of several tons each, so it adds up quite quickly. I don't think we're ready to release many details about this effort yet, but it will be forthcoming in the months ahead. And with that, I'm going to pass it back over to you, Hank.
Great. Thanks, Eric. So I'd like to shift the commentary to the commercial opportunity. As we've discussed before, we have a unique opportunity that combines strong organic adoption of 3D printing and advanced manufacturing modalities utilizing high-quality spherical alloy powder with the step function growth associated with the strategic imperative to reshore capabilities in critical minerals, advanced manufacturing, and defense production. Not to be confused with alloy powder that's processed from scrap or recycled metal. Amaero produces high-quality spherical powder with full lot traceability of feedstock, just as Eric described. And this is an important distinction the market will come to better understand. The principal industries that we plan to serve include aerospace, defense, and space. They're large TAMs or markets. They're growing. And the use of advanced manufacturing modalities that utilize powder is displacing legacy forgings and castings, importantly. Note that applications such as consumer electronics are not a focus market. These applications don't require mission-critical quality nor strict provenance for feedstock, which will be a hallmark of our production. Next slide, please. The slide makes two important points. Number one, Amaero is well positioned as an alloy powder producer that can be highly responsive to customers' demand pull, i.e. dedicating this first atomizer to C-103. And as an alloy powder producer that has a singular focus on producing high-quality spherical powder. In the case of other companies, whether it's ATI, the large company, powder is maybe 1 or 2 or 3% of the total revenue. In the case of AP&C, it's a small subsidiary of General Electric. This will be the entirety of our business and our singular focus. Amaero's atomizer produces a world-leading yield of the highest value powder spectrum. The atomizer will be the first of the next generation technology to be installed in the US and only the second to be installed in the world. Number two, we described Amaero's opportunity as titanium and specialty alloy powder production. However, the hypersonic arms race has the potential to create sustainable demand for C-103, a specialty powder that is priced at multiples to Ti-6-4. Next slide, please. I hope you'll find this to be a very interesting slide as we talk about refractory and specialty alloys and really highlight what will be the significant near-term opportunity for Amaero. First point, Amaero has a differentiated competitive position. Number one, C-103, the niobium refractory alloy, has a melting temperature of 2,350 degrees Celsius. Our atomizer technology is rated to operate at a higher temperature than many of the other atomization technologies. And Amaero's technology, as Eric suggested, provides contract-free process that mitigates contamination. Number two, Amaero's atomizer arrives in the US on Thursday. The atomizer plant had an approximate 15-month build. And number three, Amaero will dedicate production runs for the first atomizer to C-103, which provides approximately 200 tons of annual production capacity. The next point you see on this slide, development and commercialization of the hypersonic market, is critical, and the supplies of materials such as C-103 is the enabling imperative. See the quote in the bottom left from Air and Space Force's report. I read, current hypersonic supply chains, including supply of critical materials, namely powder, are incapable of supporting deployment of hypersonic weapons at scale, and lead times have grown exponentially. This is a critical report from May of this year. It gives you a sense of the urgency, the critical nature, right, and the collaborative forces come together to pursue this project. This is a backdrop as for the opportunity or the TAM. It's expected to grow fast, as you see up in the market potential data, and to be an enduring feature of the defense landscape. Moreover, C-103 powder is important in space applications as well. Next, please. We won't go through this. We will be posting a new website. You'll get a sense on this of our new branding. We will be posting a new website that is going to be much more substantive than what we've had in the past. We'll post articles such as this, will be clicked through. We will also be populating it with Fred Yelton has significant published research, as does Eric Bono, as does David Schmidt. We'll be building libraries of peer-reviewed research of our executive team and work that they're doing. Next, please. Finally, last topic before we go into questions, and Eric hit on this. I must first say, before I go to the point of this, I feel like, I've been working very, very, very hard for 15 months to get us to this point, to make strategic decisions, to reorient the strategic strategy of Amaero. The board has been incredibly helpful in this vein, but now we have assembled a world-class operating team and technical team. And as an example, Eric Bono, Fred Yelton, David Schmidt, it so happens consolidated hip manufacturing, near net shaped parts, is an area that they've done a lot of research over the years. They've got groundbreaking work and a lot of experience. And I've already heard this firsthand, how well received it's been by key stakeholders that we've spoken to, including U.S. federally funding defense labs. To close in this presentation, if you'll notice at the bottom left, to give you a sense of the importance of this imperative, the U.S. Department of Defense has identified that challenges relating to production capacity for forgings and castings are one of the 4 most critical threats to national security in the U.S. According to the U.S. Government Accountability Office, 9% of the F-35 fleet is grounded. It's not airworthy. Much of this is due to long lead time for replacement parts that need to be forged or cast. It's an opportunity for us to solve a vital industry problem and at the very same time improve the unit economics of our operations. What I'd like to now do is turn to a few questions, and typically we would open this right away to investors. I think given the nature of this week, a couple of questions I'll lead with that would be top of mind to me as an investor, and then we'll open this up to questions from you. The first and most obvious from me would be the question, why was Amaero in a trading halt for 2 days this week? It certainly doesn't seem apparent by the presentation that we lodged today and the announcement that we lodged today that was necessary. A little bit of background. Once we made the decision to shift production of the first atomizer from titanium 6-4 to C-103, we had an obligation to notify the ASX, as we felt the development could have a material effect on the stock price. Amaero submitted a request to the ASX prior to the markets open on Monday to halt trading, to lodge an ASX announcement, and to lodge an accompanying investor brief or presentation. The ASX concluded that certain proposed disclosures were unsuitable due to the forward-looking nature and the absence of binding offtake agreements. We continued discussions over 2 days. We iterated the announcements and agreed to exclude guidance beyond fiscal year 24 and not to provide any guidance that wasn't supported by binding contracts. So again, a bit of background on why we were in a trading halt, perhaps not so apparent once one sees the announcement. A couple more questions and we'll turn this over. Another obvious one seems to be, why did Amaero shift production from TIE 6-4 to C-103? We believe that the shift from TIE 6-4 to C-103 will benefit the company and that will be accretive to the company's value. We routinely have discussions with industry participants, and I say we, I'm really talking about Eric. I'm talking about Ken Davis, our VP of corporate development, others in the organization that have decades of industry experience and relationships. They routinely are speaking to defense prime contractors and U.S. federally funded research and development labs. And we've had significant conversations about this very topic. Given that Amaero's manufacturing facility is located in the U.S., and given that we have the ability to dedicate production of a next generation atomizer to C-103, we believe there is significant unmet demand for domestically sourced C-103 powder. Hypersonic weaponry is amongst the highest priority for U.S. national security, and in turn is amongst the highest priority at Department of Defense, at National Defense and Science Labs, and at prime defense contractors. Yet, as stated in the earlier Air and Space Forces report, current hypersonic supply chains, including supply of critical materials, are incapable of supporting deployment of hypersonic weapons at scale, and lead times have grown exponentially. I think this gives you a sense of the imbalance in supply and demand, and moreover, the critical nature of the timing to complete these commercialization projects. Amaero's advanced atomizer technology and our ability to dedicate the first atomizer production allow us to stand up annual production capacity of approximately 200 tons per year of C-103 powder. And lastly, how do you expect the revenues of the first atomizer to change? We were silent on this in the announcement and the presentation. Though many of the defense programs are classified, Eric Bono and Ken Davis have had discussions with their network of longstanding industry relationships, including distributors, suppliers, and end users. Based on indicative current market price of C-103, as compared to the price of Ti-64, we expect a significant improvement to revenues and contribution margin from the first atomizer. With that, and understanding that in some of these areas we're not prohibited or permitted, that is, to be more explicit, let us turn it over and open up to your questions. As always, I very much appreciate people taking the time to join us on these calls. Russell.
Thanks, Hank, and thanks, Eric. So just a bit of housekeeping before we jump into the questions. The way that questions work is twofold. One, you can, of course, use the Q&A form where you can type up questions, but what is preferred is if you raise your hand, as I see Miriam Lee has, and we will unmute you one at a time to ask your question live, and then Hank and Eric will take the opportunity to answer that question. With that said, Miriam Lee, I'm going to unmute you now so you can ask your question. Miriam, you are allowed to unmute yourself.
Miriam, I think on your screen, there we go.
Yep, there we go.
You can hear me?
Yes.
Yes, Miriam, how are you?
Oh, well, thank you. And thanks for answering all my emails that I've sent over the last couple of months. I've got 3 questions. Just as I asked before where the titanium was coming from, have you got a source of niobium organized yet? And in what form? You know, raw material or in bars, or how does it come?
Why don't you go through the other 2 questions as well? I'll make a note of these, and then we can go through each of them. Miriam, might be easiest.
Oh, right. Okay. Well, the new process that we hadn't known about before, is it covered by a patent or patent that you're going to have to pay for, or how is that organized? Because obviously the new people who have come to the company have brought that new process, and I just wonder what sort of intellectual property it might fall under. And the last one is, have you actually had, you probably can't reveal this, have you had discussions with potential clients, or are you just assuming that if you produce the substance and you know it's going to be in high demand, that the clients will come?
Great. I think I caught all that. So Miriam, let me repeat these. Eric, I'm going to turn many of these to you.
So those are the 3.
Yes. The second question, let me begin with, and to clarify that I understand, I believe what you're asking about is not the atomization technology or process for manufacturing powder, but for the consolidated HIP manufacturing. Is that correct?
Yes.
Okay. So Eric Bono and Fred Yolton and Dave Schmidt have worked together for, Eric, how long? How many years?
Yeah, I mean, probably almost 20.
So a little bit of background on HIP and what's entailed here. One of the reasons this is a difficult capability for others to compete against us is advanced material companies have material knowledge, in this case, powder metallurgy knowledge. Manufacturing companies, whether it's 3D printing or other printing, they've got manufacturing knowledge. In the case of HIP, it requires integral knowledge and deep knowledge of both. So for example, and I'm going to turn this off to Eric in one moment, really what we will do is we will engineer, design, and manufacture the cans that you can almost think of as a mold. Those cans are filled or quote unquote packed with powder. But the very packing of that powder relies on very, very sophisticated mathematical models. Those mathematical models predict shrinkage, predict warpage, predict a lot of things. So customer will give us what they want the end component to look like. But then we've got to decide what can do we build that results in that end component. Eric Bono, Fred, and David have done a lot of work in this area, and we acquired their intellectual property, including financial models and numeric modeling, computational analysis that will aid us in doing this work going forward. And then, of course, that work will continue to be refined. I'm going to let you comment on that any way you would like, Eric. And then the other two questions, I believe, and just make a note here, let you comment on, as we think about supply chain, maybe talk a bit about where niobium comes from as an element, but then C-103, the alloy, right? What do we expect the issue there from a supply chain and securing that? And how might we work, by the way, with our end customers to the extent they have their own supply chain scale to do that? And then finally, now I just went blank. The last I make a note here, I can't even read. The last comment was?
Discussions with potential customers, if we have them.
Yes. All right. I'm going to let you take all those. Thank you.
Okay, sure. So on this HIP near net shape side, it's in concept not terribly difficult to understand. So as Hank said, you have this, what we call a can, but it's a mold, and you load the mold with powder, and then you have to take all the gas out of it, and then you do what's called hot isostatic pressing. So you heat this thing to 1800 degrees and literally 15,000 psi, and it compresses this can or mold, which in turn compresses the powder inside. In practice, it's quite difficult to know how do you design this can or mold so that you get the final component out. Once you figure out how to numerically predict what this can looks like, now you have the challenge of actually building that can, which can be quite difficult. And that's where some new exciting IP is coming from, and where we are talking to some partners about ways to manufacture these cans that really has never been done before. So that's, although we have some IP, there's more and new exciting IP, I think, on the horizon. As far as where does the niobium come from? So I mean, it's mined. I think the biggest mines are in Brazil. But what we would get as raw material would be bar. So like 100 millimeter bar, something like that, by a meter long. We are right now working through potential suppliers with long-term agreements on acquiring this bar. It's not something you can run to the store and buy, and it's very pricey. There's an element in C-103 called hafnium that is, I believe, the highest. It's rising higher in price than any other element on the periodic chart. So along with the C-103 opportunity, there's also opportunities for alloy development to replace C-103, sort of the next generation. We are set up to do that work as well, which is also exciting. And then the last one was potential discussions with customers. Yeah, certainly nothing we can talk about. But yeah, there's not, this is not a material that has 10,000 customers, right? It's got a few, it's got a handful. We know who they all are, and they are all fairly open and fairly desperate for a production scale and reliable supplier. So those communications are happening and they are being welcomed by the other side. So I think this will turn into very quickly a market pull scenario instead of us pushing it. I think that hits all of them, Hank.
Thanks, Eric.
Yeah, thank you, Miriam.
Thanks, Miriam.
We're going to move to just a question that we got via text. We'll kind of jump back and forth. So the question was if you could just talk slightly about the financial impacts of moving the business from Melbourne, and the company's ability to retain people that hold the company's IP in their heads, basically looking at the cost from an HR perspective.
So as it relates to moving the business out of Notting Hill, as you might recall, I believe it was July of last year, we took a restructuring charge. That restructuring charge has been largely expensed. I think we might have 200,000 Australian left in that restructuring charge, but it's been largely expensed, and we do not anticipate any significant ongoing expense to the restructuring in Australia. There will be more news to come. We will make more changes as it relates to the organization, as well as our real estate footprint and our capabilities, but we do not expect that there will be an expense associated with that. One of the very important things, and this is indicative of my private equity background, and it's indicative of my early conversations with Eric. Early conversations had nothing to do with Amaero. He was one of the very first people I was pointed to when I invested in this business as someone I needed to get to know that was knowledgeable in the industry. But as I began to try to convince him of why he should come to Amaero, as a private equity investor, what I care about is aligning economic interest with our other investors. By the way, Pegasus owns almost 40% of the shares outstanding. I believe it's 39.6%. And also align our economic interest and our incentives along with employees. We will have an equity ownership culture of all employees. And that will be particularly the case with our senior employees, of which this business is predicate and built upon their experience and their intellectual knowledge. We hired Eric a month ago, but what we got was a culmination of 28 years experience, right? And we want to reflect that. And I hope that members of our senior executive team, that this will be a life-changing event for them as we build this company and as we realize the value attached to it.
Thank you, Hank. Moving back to attendees who raised their hands. Phil, I'm going to allow you to unmute yourself. Phil, you should be able to unmute yourself now.
Yeah, thanks, Russell. Hi, Hank. Phil Kaywood, Wentworth Securities. Firstly, well done on all the rapid, I guess, progress since relocating to America, including the personnel that you've added. Could you just touch on, obviously last week you mentioned obviously a saving in the factory fit out, which is great, and I can only assume that going to the C-103 powder, albeit a sort of similar process with the atomizer, that you're focused on that for. I assume you can get earlier cash flows, potentially have the powder certified quicker. Sort of pulling everything forward. So maybe you could just clarify that. And then I assume also the C-103 seems a more expensive product from my research on the internet. So you probably get larger margins, richer cash flows for Amaero.
Great, Phil. As always, thanks for your continued support. So I think I've got three questions here, and please add if I miss any of these, and Eric, feel free to jump in as well if there's anything that you want to add. So the first question pertains to the fit out of the facility and the capital investment in equipment, and to what extent do we have to have any additional expense associated with C-103 from what we had already planned for with Type 64 and what had been announced as ultimate capacity or ultimate installation of 4 atomizers? The answer is no. There's no incremental expense whatsoever. If you think back now in an iterative basis, and this is part of, as Eric can tell you, that we've ingrained in the culture to make damn sure we undersell and we over-deliver, right? That we are absolutely persistent, right? And at all times mindful of exceeding expectations that we've established. In the CapEx, we've come down materially twice. Eric, I'm in Arizona this week. I stayed here given the conversations with the regulators to make sure that I was available. Eric is hosting the entire team from Amaero, as well as outside consultants. I don't know how many people we have back there, Eric, this week. We've got 20 odd people, I might guess, at the facility. And they're doing, we've already got all the preliminary drawings for engineering and design of the facility. And now they're going through and yet again, value engineering and the specifics, so that within probably 2 weeks, we'll have a final set of drawing, and then we can move towards as-built drawings, as well as mobilizing for construction of the fit out. So we will continue to refine those numbers as we get those. My expectation is we've managed the market to what the current CapEx is. And if we come back with future guidance, I think there's a better chance it's lower than it is higher. And it would be point number one. Point number two on qualification. I was unaware of this as well, and I was talking to Eric about this maybe a week ago. When you have alloys such as titanium 6-4 that are so widely used, then if you go to a major defense prime, you pick a name, whether it's RTX or Lockheed or an aerospace prime like Boeing, to the extent you want to get your material in their most critical parts and they pay the highest price, they will go through their own independent process of qualifying your material. Okay. We have disclosed in the past that our assumption for titanium 6-4 qualified was $180 a kilogram. There's also a market where you can drop in qualify or go to market tomorrow prior to have that qualification and sell to others, albeit it's at a modest discount to that, maybe a 15 or 20% discount, Eric?
Sure.
Okay. So in the case of Ti 6-4, we always wanted to manage expectations that we had a period of time, and we always thought it was in the kind of 6 to 12 months, that to get the highest price, we'd have to obtain that qualification from these end customers. C-103 is a newer alloy. That is not the case. We will not go through a qualification period. Now, what customers will do is they'll provide us with very specific specifications for the alloy. And obviously, we'll have to meet those specifications from a chemistry testing and all other testing that we will do. But there won't be per se a qualification process that we will go through. And so getting to market and getting to the market at the prices that we would expect is probably a more quick scenario than not. Eric, anything that you would add to that?
Yeah, I think the way I usually think about it is something like titanium that we're talking about is, I mean, it's certainly not a commodity, but it's mature. So a lot of the big primes have already gone through and spent their own money qualifying vendor X. To come along to push new powder in there's a hurdle there that we have to figure out how to cross. No question our powder would qualify, but it still has to go through the qualification process. Something like C-103, these primes do not have that incumbent supplier. Our goal is to become that incumbent supplier and to work with those primes so that we then are on the other side of the hurdle to begin with. So I think maybe that's an interesting way to look at it too.
Yeah, thanks. On the price issue, and Phil, this is an area that we had hoped to, and we would propose communicating more extensively with investors. And nonetheless, we were given guidance that prohibited that. So I think the way that I would look at it, and I've already seen a certain stock panel today. We've already got investors out there who've done their own research and have ascertained the price of C-103. What we've communicated to the market is we've got roughly 200 tons of annual production capacity. What investors will have to do is they'll have to go out and do a little bit of research. What's the price of C-103? And I think you'll quickly ascertain it is significantly higher than the price of Ti 6-4. We can't comment further on what that price is, but we would expect that the price would be significantly higher, and revenue is simply a function of production capacity times price, right? And so that would imply that revenue would be higher. On the margin structure, I would say that there's two things. One should assume over time the net margin structure should be about the same. Perhaps because the revenue is higher, your margin structure is slightly better. We're not assuming that going in. So we assume the principal pickup and valuation will be a top line revenue issue as opposed to a more attractive net margin issue. The higher revenue obviously allows you to more efficiently absorb fixed cost, right? And so it should be accretive to your net margin, but we're not making that assumption going in. And again, to help understand, so it's clear where the ASX was coming from, I think all the ASX is saying is, look, these are forward-looking statements. It's based on uncertain assumptions. No one knows exactly what the price market will be a year from now, 2 years from now, 3 years from now. No one knows exactly what the demand will be a year from now, 2 years from now, 3 years from now, and thus discouraging these forward-looking statements. And likewise, the view is you do not yet have an offtake agreement signed, and so it implies supposition, right? It implies something that is not certain, and that was the ASX concern, right? In fairness to them and helping try to explain where they're coming from. But in turn, until we sign an offtake agreement, we can't comment further on the indicative pricing that we're hearing from the marketplace.
And I do just want to comment on that quickly. I know we are getting a number of questions on the Q&A forum asking for more information on that pricing and financing. And unfortunately, as Hank said, we are not allowed to comment on that right now. So just please keep in mind if I don't get to your question because it was asked about that, that's the reason why. But thank you for asking the question anyways.
Yeah. The second one, Hank, Anti-Inflation Act in the States, we see it here with resource companies now that you're reshored in America. And it seems like this is a critical material for the government. Are you in discussions, or do you think it's realistic to assume you'll get some government assistance across the board from the federal level? Obviously, state levels chipping in, but can you just talk around the, I guess?
Yeah, let me comment on what the big picture opportunity. I'm going to turn it over to Eric because he's been through this, right? I'm speaking theoretically, and Eric can share, actual data points, if you will. So if you look at the Inflation Reduction Act, the CHIPS Act, and Defense Production Act, there's really three things that cross those, and there's only three things that I'm aware of: critical minerals, advanced manufacturing, defense production. All right. There's very few companies whose business spans all three of those, which Amaero's does. That would imply that we will likely be well received and that there would be funding that we would qualify for amongst those. Has that been a priority to pursue? The answer is no. The reason for it is the very nature of these federal programs is, and again, I'm going to turn this over to Eric and he can comment on having gone through this process. These are funds that are 12-month, 18 months, maybe even 24-month funds. Now, sometimes they will back funds. They will reimburse you for expenses that you've already had, but we're not likely to have that money in the near term. And so we've focused on strategic planning initiatives, capabilities that we have to get installed, and then capital that we'll fund that with in parallel. And one of the things that Eric and I are talking about right now from a corporate development standpoint is, do we need someone that will be his entire role? Eric, let me turn it over to you and let you talk about your experience professionally dealing with this.
Yeah. So it's actually a fantastic question, Phil, and it's something that we do need to put some focus on because it's expensive, right? And these elements and alloys are critical to many defense applications. We have not spent a lot of time or energy lining up federal opportunities at this point, but we will. So as Hank said, these things can take 18, 24 months to get through, but once they're through, they can be very substantial. What you have to be careful of, and what we will be extremely careful of, is we will only go after programs essentially that we are going to do the work anyway. In other words, we're not going to just be chasing government money. That's I think a dangerous path that we have to be careful of. But our ambitions and where we want to go do line up with national security initiatives. So government funding should be and will be a part of that, but we just have not pursued it a lot yet.
And I would add, Eric, as an example of that, Oak Ridge National Lab was kind to step forward. They're the ones that signed economic incentive agreement with us when we decided to come to Tennessee, and indicative of an interest to continue their collaboration I do expect we will have more concrete announcements in the future as these things are codified and we have contracts. But you might imagine these are areas of which they have, it's communicated to them and it aligns with their strategic priorities. And then they have pathways to funding, right, directly with that. And so one could also imagine, as we develop a relationship with National Defense Labs, that the very collaboration and research we do, which will be applied, there'll be commercialization with the National Defense Lab, could have funding attached to it or lead to funding as well. So there's a number of vehicles that will successfully go through this.
It's okay. Just one last question from me, and it's for Eric. Eric, obviously, I looked at your experience. You've got a great amount of experience, and there's global shortage of skill set in the metallurgy and powder side of what's happening. I'm just curious as to why you joined Amaero and I guess your vision outside of Hank's of where you think Amaero's going and the demand from the global side of the marketplace.
Yeah, so it's a good question, right? So I mean, I am moving my family. I have kids in high school, right? So we know how difficult it is to do that. I'm moving my family across the country to come here. That's how much I believe in it, and I believe in Hank's vision. And it's pretty simple. It's to fill a national hole, right? A void that we have for these really high quality materials. It's powder. I like to call it materials. As well as components. And we will have the highest quality powder and the most abundant stock of it to sell. So it was a pretty easy sell. Hank's a good salesman, but he had quite a good product behind him. So I was very anxious to jump on board. And we really haven't had much trouble attracting the other talent that we've brought in so far, because it's a very easy path to see what we're on. And Hank has developed the culture, and we are nurturing it, that as people come in, you're not coming in really as an employee, you're coming in as a partner with ownership in the company. And so we all are extremely well aligned with what the vision is and how we get there. And that just makes it a fun place to come to work to. And we're all working hard, right? It's almost 10:30 at night here, and there's 3 of us in the office. Yeah, I just think it's the opportunity and the alignment of values that we all have that was attractive to me.
Hey, Phil, I would add 3 other companies I know of have tried to hire Eric, and was their top hire that they've tried to hire over the years. Eric was the first person I was pointed to as I was trying to learn this industry. Eric has lived in Pittsburgh his entire life. As you may well know, in Pennsylvania, a lot of the foundry industry is really based there. And these are big commitments people are making. Right, they're moving families, they're leaving places they've never left before. But as he said, we've got 3 people in the office at 10:30 at night. This is not. I don't want to hire people that want an 8 to 5 job. That's not the team we're putting together. We're putting a team together that understands and believes that we've got a chance to do something very, very significant, and that's the team we're putting together.
Yeah, excellent. Okay, thanks, Eric, and thanks, Hank. Well done, and look forward to the progress.
Thanks, Phil.
Thanks, Phil. We're going to move on to some of the written questions as well. Just Paul Bolesta said, keep up the good work, Hank. You've previously stated that the higher spec products could take up to 2 years to get independently verified. Is this still the case with C-103?
Yeah, thank you, Paul. And similar to what we had said before, and mind you, when we've tried in the past, we've always been very mindful of any guidance that we've given, and we've always tried to give guidance that we felt we could outperform, right? That we felt we could exceed. And so, a lot of times when we talk about ramping up capacity, there's 2 components to that. One of which is how quickly can you ramp up the operational capacity and achieve the quality that you need in the material. The other piece of it is the demand there. Right. And you've got to do both of those. And so we're trying to be mindful of both those as we go forward. I think as far as standing up the operational capability, it'll take no longer as far as C-103. As far as qualifying the material, as we talked about, it may be a shorter period of time and less obstacles get in the supply chain, given the critical nature of the supply chains we've talked about. The other question related to that was?
So yeah, I was just asking if that was still the case. So that was that
Yeah,
answer.
yeah. So I think if anything, Paul, with C-103, the timelines we may have discussed in the past, we're confident that we probably pulled forward those timelines, given some of these things that we're talking about. Not to mention, again, having this facility that now is essentially built, the shell, and now we start the fit out, finding a way, and I give Eric incredible credit. I pursued this with the German manufacturer 3 months ago. I pursued this with others of our consultants, and it was concluded we could not install this atomizer in the existing facility. Eric looked at the same problem the way that I did and said, but why not? And again, we've got all the consultants, we've re-engineered, we're highly confident we can do it. That alone probably saves us 6 months. And it's risk. Time is risk. Time is money, it's expense, and it's risk, right? So what I hope that you will see as we get into next year is that we will continue to outpace guidance that we've given. And as I also said about a month ago, I would expect the cadence of these communications, the cadence of these milestones will pick up and increase.
Thank you, Hank. Now, I'm actually going to combine two of the written questions we got because they were asking the same topic. So Kevin Anderson and Paul Balesta asked very similar questions regarding BNNT. And so the question was twofold. So there's two questions on it. The first was that Amaero had developed a project to develop alloys including BNNT. The question was, is this still being pursued? And then additionally, is there any possibility to use the work that's been done to including BNNT to produce additional super alloys? Paul specifically mentioned NASA's use of BNNT in their space programs.
So let me preface my comments that I have a not deep knowledge in this area and never want to overstate what I know. So Barry Finnan in Australia had worked with a partner, another public company on this project with some technology that they had developed that we were going to commercialize. The early tests that we did were challenging, and it hasn't advanced very far, and I don't necessarily expect that it will advance further. It may well be there's other applications of BNNT over time. So, you know, not to say that we don't re-engage with that, but it's not a priority right now as far as a development project that we're working on.
Excellent. We're going to swap back over to Finola Burke. She is raising her hand. So Finola, I'm going to allow you to unmute yourself right now. You should be able to unmute yourself.
Great.
Thank you.
Thank you, Russell, and congratulations, Hank and Eric, on the announcement today, and congratulations, Eric, on joining Amaero. We're very privileged to have you on board. I just had a couple of questions. Most of them have been asked, but firstly, just wanted to get a sense from you as to what the plan would be in terms of TI-64, in terms of the mix that you would see if you would continue to do production. I think you were talking about initially doing 1,200 tons a year of just the TI-64, but if you're adding in 200 tons of C-103, are you going to wait and see? And on what you would do with the extra 3 gas atomizers that you're planning to put in? And secondly, Hank, could you give us a bit of an update on the strategic investor that you've been looking for the business, just where that sits and how you sort of look at the capital structure of the business going forward?
Great. Thanks, Finola. And as always, thanks for your attention to the stock. Plan for TI-64, I'm going to loop that in with your plan, your question relating to the next 3 atomizers, and also restate something to make sure there's not any confusion in the marketplace. So what we've talked about before is each atomizer having annual production capacity of about 200 tons. It's a little bit more than that. I think 204 is what we've talked about, but we'll call it 200 tons a year of annual production capacity. Thus, 4 atomizers, which we've talked about in the past, would have a total production capacity of about 800 tons. So in general, that's been the quantum of the production that we've talked about. Now, that being said, we're landing our first atomizer now, and we haven't ordered the second one. And the second one is about a 15-month build. You know, one of the things that one might expect from us is maybe sooner than later, we announce advancing the purchase order and moving forward with building these next atomizers. I think that would be a reasonable assumption to make. We will have a period of time. If we order that atomizer today, it's delivered, let's say 18 months from now. Just as we did with this first atomizer, the production run that we dedicate at the time will be driven by demand pull. It won't be, we're going to make X and try to find a way to sell it. We're going to look at what is the demand for, the greatest for, the most attractive unit economics, and that's where we will focus. One of the real benefits of our technology versus some of the other technology that's a larger scale production is we can dedicate an atomizer to C-103 or Ti-64, but we can also run what we call small batch production. So that is, you might, over the course of a month, run one alloy for 7 days. Then you stop the equipment, you clean the equipment, you change over the material, and you might run a different alloy for 7 days and repeat that process. So that as opposed to being dedicated to a single alloy, you've got multiple alloys in a smaller batch that you can run through that. That is a much more difficult thing to do for larger industrial manufacturers. And that will be one of the benefits. And keep in mind, some of the highest value specialty alloys, implicitly, they're using smaller amounts of. So you're not getting a 50-ton order of some exotic specialty alloy. You might get a 2-ton order, but that 2-ton order, the price might be 20 times Ti-64, right? So it's very attractive from a unit economic standpoint, but it's more difficult from a production standpoint. But we will have time to make that decision, and we'll let the demand tell us where to go. On the strategic investor, we've, what we were very clear about going back 4 months ago is that we would not raise equity until the price essentially re-rated. That we were highly confident that when we did raise equity, it would be at a higher price. Back when we made those comments, we were probably at 10 cents a share, whatever the case may be. We've also commented that I don't think it'll be necessarily important for us to raise capital in the traditional discounted method. We'll see. We've got, we've got interest on the financial side. We've got interest on the strategic side. On the strategic side, Finola, the only thing that I would say is what we want to be mindful of, and this is kind of my finance M&A background, you don't want to take capital, even if it's available, if it's going to limit your commercial options in the future, your strategic M&A options. So as an example, there are certain companies in our industry who do not produce powder that we will produce. They would love to have that powder in their distribution network, right? So they may say, we would love to invest X, but what comes with that investment is a commercial agreement. That commercial agreement could later limit our M&A options or other strategic options. And so it's something we'll want to weigh and be very mindful of as we look at that going forward. But we will report more as we have more concrete things if you will to report.
Great. Thank you, Hank.
Thanks, Finola.
Thanks, Finola. One thing that I just was hoping you could elaborate a little bit more on, Hank, was the downtime that it takes to switch between the alloys in terms of cleaning. You mentioned that it was, something that was definitely viable, and doing a 7-week run in a month and then cleaning and switching. Could you just elaborate on what the downtime would be there?
Yeah, now we're above my pay grade. So if I somehow made an assertion, I back off that assertion. I'm gonna turn this over to Eric, who's far more qualified. But what I will tell you is, look, from a process standpoint, there's things you adapt, right? So these atomizers have cones, essentially, right, where the material goes in. So you could dedicate different cones to different materials and thus not have to clean those cones and make the changeover more quickly. But the nature of what we're doing from a contamination standpoint is between materials, you have to extensively clean this equipment and prepare for changeover. So it's not something that you would want to run a batch for a single shift, right? And then clean over for, you'd be very thoughtful about the way you plan this production. Eric, I'll let you comment on that further.
Yeah, I mean, I don't think we are in a position to comment how long it will take to be able to do those changeovers. In an ideal world, the atomizer is dedicated to one material. In a practical world, it's not always the case. So you have to have processes in place that can allow you to clean and switch over, and it's common practice in the industry to do that. But yeah, I don't think we're in a position where we can say how long it would take at this point.
I think that, Russell, what you could conclude, though, is if you have an IGA or an atomizer dedicated to a single alloy, okay, we've given the advice based on specs from the manufacturer, we expect capacity of about 200 tons a year. If you're running multiple alloys, presumably your capacity is less, right? Because that change over time, and thus would have to be offset by higher prices that more than compensate for that disruption in the production cycle. And that's the way you would think about it.
Excellent. Thank you, Hank and Eric. We've had a number of questions regarding financing as well. I know you just touched on that, Hank. Is there anything more that you would like to or can discuss at this time regarding the financing? We've had a number of written questions around that topic.
No, we've been transparent. We tried to be more transparent. You know, one of the nice things about what we're doing, unlike if you think about other companies that have very, very large and long-lived capital expense budgets, right? Our capital expense budget is short-lived. It's essentially 2000 calendar year, to be clear. It's essentially calendar year 24. And then there's a bit into calendar year 25, all right? So call it over the next 2 years. And you make that capital investment and you now have installed the capability that's long-lived, right? 20-odd years. So we will need to go out and raise capital. We've communicated that to the market. We expect that'll be the case. We expect that there's interest in doing so. As the largest shareholder, I'm going to be real mindful to minimize dilution the way we go about that, right? And this isn't a company where the CEO owns 1% of the stock and is paid a very, very large salary. We're a different company than that. And our interests are very aligned with shareholders. And so we want to raise the capital that provides sufficient growth for the opportunities that we have, and yet do so in a way that minimizes dilution of existing shareholders.
Excellent. Thank you, Hank. Moving on to Doug Smith. I'm going to allow you to unmute yourself. You can unmute yourself. Thank you, Doug. Doug, we currently can't hear you.
Can you hear me now?
Excellent.
Yes.
Thanks.
Hello, Doug. How are you?
Hi, guys. Good, thanks. Great presentation. Thanks for your time. And following on from Miriam, there's a question about the inputs and probably some more expansion on Tennessee. So where do you get the argon and the power, the other two key inputs, as I understand? And a second question, how would that compare to operating in, say, Europe? I know there's some incumbent producers in Sweden that do metallurgical powders, and do any of them actually produce C-103? So a couple of questions there.
Yeah, so let me take that first, and I'm going to pass it off to you, Eric, as far as what other producers produce CO13. Very insightful question, Doug, and you're exactly right. So if you look at a cost of goods sold, our number one cost is bar, or feedstock, followed by argon gas, followed by electricity. One of the things that Eric and his colleagues have done very successfully in the past, and it is something that we will likely pursue, is we have strategies that will significantly minimize the cost of argon. I'm not at liberty to comment on that, but we think we'll have a real competitive advantage as it relates to argon, number one, as far as our approach. Number two, one of the benefits of being in Tennessee Valley is, I think within probably, mind you, Volkswagen is 2 exits down I-75 from us. I think probably in a 5-mile radius, I believe there's 3 major industrial gas producers, right? So unlike Victoria, where we are hard pressed to have a single industrial gas producer that had very, very high prices, not at all the case in the U.S. So we've got a great installed ecosystem, great service ecosystem, but on top of that, given some work that Eric's done in the past, I think we're going to have a real competitive advantage with argon, which is a significant component of cost. In addition to that, as we alluded to, we've signed a 10-year contract with Tennessee Valley Authority, 10-year electricity subsidy. Those rates will be on the order of, well, in fact, I can tell you, we've got the illustration, but it's 5 to 5.2 cents US per kilowatt hour. So call that 7.5 cents Australian per kilowatt hour. It's slightly below where we're going to be on subsidized electricity in Abu Dhabi. And it is 85% below where we'd be in Victoria or Notting Hill, right? It's a significant reduction. In the US, we will be amongst the lowest cost producers from electricity in upstate New York, you've got hydropower. You also have that in Canada, in the Quebec area. That's also a very low cost electricity. But essentially your hydropower in that area and us will be the lowest cost in the country. And I am not aware of anyone with lower cost, but there will be others with comparable cost. Eric, you want to, and by the way, in Europe, what I would only comment here, and I'll pass it off to Eric, it's very bifurcated. And I spent a lot of time looking at this market when we're going to stand up production in Abu Dhabi. You're right. Most of your production is either in Germany or in Sweden. Sweden has very attractive electricity rates given hydropower, maybe even slightly lower than us. I mean, very, very attractive. Germany, on the other hand, given the Ukraine conflict, higher than Victoria, right? You're on a US basis, probably 40 cents a kilowatt hour in Germany, going higher, given the challenges that we have in the Ukraine conflict. And so a lot of the production that heretofore, I don't know the exact number, but probably close to half the European powder production was in Germany. Maybe it's only a third, but somewhere between a third and a half, a significant amount, is going to be increasingly price less competitive because of that energy issue. The last point I'll make and pass over to Eric, given the nature of C-103, we're not talking about aerospace. We're talking about defense programs. And so having US-based supplier is a big deal, okay? Having a US-based supplier is a big deal. Where in the aerospace market, we would readily compete against European and Canadian manufacturers. And to some extent, they're indifferent, not totally. But if they can get the right quality and the right price, right, all things equal, they probably would rather have the American. But there's other great producers. Defense is going to be a bit different. Eric, I'll pass it off to you.
Yeah, you can pass it off. I think you answered it perfectly, Hank. So when you look at specifically the question from Douglas on C-103, there's not a lot of people, period, making it in the world. But when you look at Europe, there's not a lot. And I think the reason is, there's a couple of alloys that were developed, in the U.S. and found their use in the U.S. through either space, meaning, satellite launching, or defense applications, where those are areas where I would say U.S. is ahead. I mean, the U.S. invented hypersonics. So they haven't really caught on yet in Europe. If you're selling things like nickel-based superalloys, stainless steel, there's probably more supply in Europe than there is in the U.S. But specifically for the C-103 question, I don't think we will see much competition in Europe. So as they adopt use of some of these high temperature refractory type alloys, I think we'll be in a pretty great position to supply them as well.
And part of the challenge, Doug, also is you've got some world-class powder producers like ATI, that's, the old Allegheny, or AP&C. But bear in mind, they've got big production runs and they've got production commitments for 2 years. So whereas we have the luxury of a brand new atomizer with zero production commitment, thus I can dedicate it to C-103. These other producers can't do that, right? If you go to these producers today, and we know this firsthand from conversations, they would tell you our lead time is 2 years, a year and a half, right? And back to that quote of the space agency, this is a significant issue, is the lead time of those who are capable of making it is very, very long, and thus unique situation we're in competitively having this new atomizer.
Great, thanks for that, gentlemen. Appreciate it.
Thanks, Doug.
Thank you, Doug. So Paul Balesta asked a bit of a clarifying question on strategy, specifically related to the 10-year electricity agreement. So he said, Hank, you've stated that we have the 10-year electricity subsidy. So in mind, do you think it's better to get funding quicker to so that you can then order the new atomizers, considering the long 15-month build time for each atomizer?
Yeah, I think that, and we purposely probably haven't given a lot of specificity on this, but we're going to manage, and we've done this in the past. And again, part of this is, I have a very significant investment in this company. We're going to manage a very conservative, what I view to be conservative balance sheet. We're not going to be one of those companies that runs down their cash balances in a pinch to raise cash. That will not be our approach from a treasury management standpoint, from a fiscal discipline standpoint. We ended the June 30th quarter with $8.8 million of cash on the balance sheet, I believe. And so, one should ascertain that sooner than later we'll go raise equity. And yet again, I think we will do that in a really, really thoughtful way, being sure to provide adequate runway for our growth initiatives, and minimize dilution to shareholders.
Excellent. Thank you. That we don't currently have any more open questions. I just want to thank everybody for attending. As you can see from the presentation and Hank's and Eric's comments, this is really the right place, Tennessee in the United States, the right time with everything that's going on. I mean, you can just open up a newspaper and see comments about what's going on in Ukraine, as well with China, with hypersonics. And, you know, it's really an exciting time to be involved with Amaero. So with that said, I'm going to thank everybody and call the webinar to a close.